Hello everyone, this video is going to be about transforming parent functions. And the first thing we need to do is describe the transformation before we start sketching so that we know what we're going to do. So we're going to describe in our own words. This function, the first thing I do is identify the parent function. So I see that there's a square root of 4x. So I know that this parent function is the square root of x. I also see a negative outside of the function and I see a 4 inside the function. So let's interpret each one of these parameters. The negative outside of the function indicates a reflection across the x-axis. When you have a number inside of the parent function, it's either a horizontal stretch or a horizontal compression. How do we know which one to do? If the number inside of the function is greater than 1, then we know that this is a horizontal compression. I also have to know by how much will this function compress if I compare it to the parent function. So the factor by which this compresses is 1 over whatever this number is. In this case, the compression is going to be by a factor of 1/4. So my description statement will look like this. The parent function, f of x, equals to the square root of x, has been reflected across the x-axis and has been horizontally compressed by a factor of 1/4. Once I have described this in my own words, now I can start looking for the coordinate points to sketch my parent function. We're going to look for 2 or 3 values of the parent function that we can sketch really quickly. Since this is the square root of x, all the parent functions have the point 0, 0. When x is 0 and I plug it into the parent function, y will also equal 0. So I know it goes through the origin. Also, all parent functions go through the point 1, 1. If you check, when x is equal to 1, the square root of 1 is 1. Another number I can check is the perfect square 4, which is the next number after 1 that's a perfect square. Square root of 4 is 2. And I can also check 9, which is the next perfect square. The square root of 9 is 3. So here I have 4 coordinate points that I can plot in my graph to sketch the parent function. We always start by sketching the parent function. So 0, 0, there's 0, 0. I also have 1, 1. Next one is 4, 2. And the next one is 9, 3. Right there. I'm going to draw this parent function with dashed lines and an arrowhead to indicate that this function continues forever. The next thing I'm going to do is I'm going to work with the horizontal compression of 1/4. What that means is we're going to take our x coordinates, here it says multiply the x coordinates by 1/4. So I'm going to go ahead and take all my x coordinates and multiply by 1/4. So this is what it looks like. My y coordinates I'm going to keep exactly the same. So my y coordinates are 0, 1, 2, 3. Those I don't touch at all. And my x coordinates here, I multiply this x by 1/4. That's 0. I multiply 1 times 1/4, 1/4. 4 times 1/4, that's 1. And 9 times 1/4 is 9/4, which I can change into a mixed number and say that this is 2 and 1/4, comma 3. These are equivalent coordinate points. And now I'm going to sketch this compression. So for this compression, I'm going to sketch 0, 0. I still have that origin. 1/4, 1. That means go 1/4 of the way to the right and then up 1. So about here. 1, 2, go over 1, up 2, right there. 2 and a fourth, 3. So go over 2 and a little bit more and go up 3. There you go. So you can see that horizontally, this parent function has been compressed. It has moved all of its x coordinates have moved closer to the y-axis. So there you have the compression. But this is not my final graph, so this is why I'm sketching it with a dashed line. For my next operation, I can't forget this reflection here. So that's the last thing I'm going to do. And I'm going to do that by reflecting the points that I plotted here, these here, I'm going to reflect across the x-axis. So that means if I fold this graph in half along the x-axis, all the points here will match down here. We'll make a carbon copy of them. Okay, so that just means that the y values of these coordinates will change to their opposite signs. So 0, 0, that stays the same. I will still have that origin. The next one is 1/4, 1. But since I'm reflecting across the x-axis, it's going to be 1/4, -1. So I'm going to go over a fourth and go down -1. So notice that this is like mapping that first dot that I had plotted here. The next one is 1, -2. So 1 and go down -2. There it is. The next one is 9/4, -3, or 2 and a fourth, -3. So 1, 2 and a fourth, and then go down -3. There you go. I have my 3 dots, and now I can sketch my final graph, which looks something like that. Okay, there you have it. That's your final graph, and once you're done with your final graph, please label it negative square root of 4x. And you're done. Hope this helps. I will make another example using horizontal stretching. I'll see you in the next video.